In section 9.4, you learned how to solve quadratic equations by factoring. This video will work problems 26, 27, and 28 found on page 571. The learning target for this section is I can solve quadratic equations by factoring. The key idea for this section is that some quadratic equations can be solved using the zero product property. Now, the zero product property states that for any real number a and b, if a times b equals 0, then a equals 0 or b equals 0. I want you to think about this statement. In order for the product of two numbers to be equal to 0, what we know must be true is that one of the two numbers must be 0, or one of the two factors. Either the first factor is 0, or the second factor is 0. That is what this property is stating. When we apply this to quadratic equations in factored form, such as x plus 3 times x plus 2 is equal to 0, what that tells us is that either the first factor is 0 or the second factor is equal to 0. And knowing this will enable us to solve these equations. Now, sometimes it is useful to write the quadratic equation in standard form before solving. The problems that we are about to work, we're going to have to do that. Write those equations in standard form before we solve them. Now look at problem number 26. A box shaped like a rectangular prism has a volume of 280 cubic inches. Its dimensions are 4 inches by n plus 2 inches by n plus 5 inches. And we're asked to find n. So let's think about what we know. What we know in this problem is we know the volume. The box is 280 cubic inches. We also know the dimensions of the box. We know that the dimensions of this rectangular prism are 4 by n plus 2 by n plus 5. Well, when you're solving a problem, first you identify what you know, and then you identify what you need to know, or what you're looking for. In this case, we are wanting to find the value of n. So we need to come up with a plan that will enable us to find out the value of n. Now remember that our dimensions are 4 by n plus 2 by n plus 5. And we also know the volume. So what is it that connects the volume to the dimensions? Well, it's a formula. So we can use the formula volume equals length times width times height to enable us to solve and find the value of n. Okay, so let's replace that volume formula with the dimensions and with the volume. So we're going to replace the volume with 280, or replace V with 280. We'll put in 4 for the length, n plus 2 for the width, and for the height, we'll put in n plus 5. Now notice that it doesn't matter which order I put the dimensions in. So I just took the dimensions here straight out of the problem and just plugged them in to my equation. I could have written those dimensions in any order because according to the associative property of multiplication, it doesn't matter the order that I multiply in. So the next thing I'm going to do is I'm going to simplify that equation. So I'm going to go ahead and rewrite it over here. And then I'm going to use the FOIL method to multiply the two binomials that are in the dimensions. So I'm going to keep the 4 on the outside, but I'm going to multiply n plus 2 times n plus 5 together. So that would give me n squared plus 5n plus 2n plus, let's give ourselves just a little bit more room here, plus 10, like that. Okay, now notice that I just used the FOIL method just to multiply those out. Now my next step is going to be to distribute the 4. So that would give me 4n squared plus 20n plus 8n plus 40. Now, some of you may be saying, but Miss Singleton, you can add the 5n and the 2n together. Well, I'm going to go ahead and do that now because I didn't do it before, and I'm going to add the 20n to the 8n. So my next step would read 280 equals 4n squared plus 28n plus 40. Okay, now, remember the statement from our key ideas. It said that sometimes, in order to solve these quadratic equations, we will need to write them in standard form. Well, if you look at this quadratic equation, it is not written in standard form. So we are going to need to do that. And in order to write this in standard form, I need to subtract 280 from both sides of the equation. By doing that, I'm going to place a 0 on the left-hand side of the equation. And then on the right-hand side, I will have 4n squared plus 28n minus 240. Now the quadratic equation is in standard form, and I'm able to solve it. Okay, so let's rewrite it over here and give us a little bit more room. And then what I'm going to do is I'm going to actually switch the sides of this equation. So I'm going to put what's on the left hand of the equation, which is the 0, I'm going to move it to the right-hand side of the equation. And what's on the right-hand side of the equation, I'm going to move it to the left-hand side. So see how I just switched the signs? Okay, or switch the sides rather. Okay, next step. Oh, this is supposed to be 240, so let's put the 2 in there. Make sure we get this right. Okay, so your next step will be to factor this. Notice that all three terms have a common factor. The common factor is 4. So we can pull that common factor out. Okay, so I just divided everything by 4. Now I'm going to factor this into 2 factors. That's going to give me n times n. And then I need 2 numbers that multiply to give me a negative 60, but add to give me 7. Those 2 numbers are 12 and 5. And in order to give me a positive 7, the 12 needs to be positive and the 5 needs to be negative. Okay, so now is where the zero product property comes in. So I have 4 times n plus 12 times n minus 5 is equal to 0. Well, according to the zero product property, that means that one of these factors, at least one of these factors has to be 0. So I'm going to take each factor and I'm going to set each factor equal to 0. So I'm going to split them up like this. That means that either 4 can equal 0, n plus 12 could equal 0, or n minus 5 could equal 0. Now you look at that and you say, well, 4 doesn't equal 0, Miss Singleton. Well, no, it doesn't. So we just know that this guy right here is discounted. He doesn't mean anything. Okay, he doesn't help us solve the equation. But we can look at the other 2 factors and we can solve them. If n plus 12 equals 0, if I subtract 12 from both sides of that equation, then n would have to equal negative 12. And over here, if I add 5 to both sides of this equation, then n would have to equal 5. Very good. Okay, we're almost done. The last thing we have to do is we have to figure out if any of these answers is not applicable to the problem. So look at both of them. If I use negative 12, then if I put that back into the dimensions, then I would have, let's go ahead and put these back in. Of course, I always have the 4, but n plus 2 would be equal to negative 10. Do you see that? Now, I can't have a negative dimension for a prism. So what that means is that that negative 12 is not one of the solutions. So I have to evaluate the solutions, look at them very carefully, and say, hey, do both of them make sense for the problem? But what about 5? Can n equal 5? Well, if I put in that 5 into all my dimensions, then n plus 5 would be 10, which means that this dimension here would be a 10. And then n plus 2 would equal 7. So that means that this guy over here is a 7. And then, of course, this is a 4. And all of those numbers make sense. So n equals 5 is the solution to my equation. Let's try another problem. You are knitting a blanket. You want the area of the blanket to be 24 square feet. So that's something that I know. So area equals 24 square feet. Okay? You want the length of the blanket to be 2 feet longer than its width. So it doesn't matter which side of the blanket is the length and which one's the width. I can use either one. So I'm going to designate that this one is the length and this one is the width. And I want the length of the blanket to be 2 feet longer than the width. So whatever the width is, I'm going to take the width and I'm going to add 2 to it. And that's going to be equal to the length. So the length here is equal to W plus 2. Now, do you see that equation there written into the problem? So that's something that I know. I know that the length is equal to the width plus 2. We want to find out the dimensions of the blanket. Okay, so how are we going to do this? Well, our plan should be to use an area formula because the area is given to us and we know the shape. The shape is rectangular, so the area equals the length times the width. So let's use the formula and let's substitute. So I'm going to replace the area with 24. I'm going to replace the length with W plus 2. And for the width, I'll just use W. Now to solve, I need to first distribute the W. So this will be 24 is equal to W squared plus 2W. Notice how I have a quadratic equation. Well, to solve a quadratic equation, sometimes I can put it in standard form and then factor it. And that's exactly what I'm going to do here. So to put it in standard form, I subtract the 24 from both sides of the equation. And I get a 0 on the left-hand side of the equation and a W squared plus 2W minus 24 on the right-hand side of the equation. Now again, I'm going to swap sides. So I'm going to write this as W squared plus 2W minus 24 equals 0. Okay, so let's see if we can't solve that. W squared plus 2W minus 24 is equal to 0. Okay, now I've got it in standard form, so I'm ready to try to factor it. Can I factor W squared plus 2W minus 24? Well, let's see. W times W. I need two numbers that multiply to give me negative 24, but add to give me 2. 6 and 4 should work. And the 6 would need to be positive, and the 4 would need to be negative. Now again, whenever you're working with factors, the zero product property says that if the two factors multiply to give you 0, then one of the two factors, at least one of them, needs to be 0. So either W plus 6 equals 0 or W minus 4 is equal to 0. Which, if W plus 6 equals 0, then that means that W equals negative 6. If W minus 4 equals 0, that means that W equals positive 4. And remember, this is an or situation. One of these two things would happen. Okay, so either W equals negative 6 or W equals 4. Now, do both of those dimensions make sense? Well, let's think about it. If W equals negative 6, that means that the length or the width here would be a negative number. Is that possible? No, that is not possible. So that means that w equals -6 is ruled out. It can't possibly be a solution. Well, what about w equals 4? Would that be a potential solution? Well, if w equals 4, then the dimensions of the rectangle would be 4 by 6, because 4 plus 2 is 6. Oh, let's make sure that's a 6. And does that make sense? Yes, that makes sense. Now notice that what we were asked to find out were, in fact, the dimensions of the blanket. We were not asked to find W, although we had to find W to get the answer. We were asked to find the dimensions. So let's write an answer to the question. So the dimensions of the blanket are 4 by 6. Okay, let's try another one. Problem number 28. You are building a rectangular deck. The area of the deck should be 250 square feet. You want the length of the deck to be 5 feet longer than twice its width. What should the dimensions of the deck be? Okay, so again, we are dealing with area. So here's what we know. We know that the area of the deck is 250 square feet. We also know that we want the length of the deck to be 5 feet longer than twice the width. So there's an equation in here. So if we call the width W, we want the length here to be 5 feet longer than twice the width. So we would multiply the width by 2, that's twice the width, and we want 5 feet longer than that. So 2W plus 5. Now we're asked, what should the dimensions be? So again, what we need to find out are the dimensions. So this is very similar to the problem that we just worked. So what is our plan? Our plan is to use the area formula. So area of a rectangle is equal to length times width. So let's set this up. We know the area is 250. We know that the length is 2W plus 5. And we know that the width is W. See how this is shaping up like the last problem? Let's distribute the W. 250 is equal to 2W squared plus 5W. Okay. Now, this particular equation is not in standard form, and in order to solve it, we're going to need to place it in standard form. That is, if we're going to be able to solve by factoring. So let's subtract 250 from both sides. And 0 is equal to 2W squared plus 5W minus 250. Okay, we're getting closer to the solution. Once we have it in standard form, then we can try to factor it. First, we look to see if we have a greatest common factor, which we don't. So then we see if we can't find two binomial factors for 2W squared plus 5W minus 250. Okay, so for this particular one, in order to factor it, I think I'm going to have to bust the B. Because if I notice, I have the 2W squared here on the front term. So you could either try to guess and check to get your factors, or you can use the factoring by grouping method that we learned in Chapter 8. So let me go ahead and just erase my parentheses here, and let's use that method that we learned last chapter to factor this function. Okay, so I'm going to come in here, I'm going to say, well, let's rewrite 2W squared, let's rewrite negative 250, and let's multiply the 2 times the 250 to get 500. And now I need two numbers that multiply to give me 500, but their difference needs to be, give me a 5. So let's think about numbers that multiply to give me 500. I know it's not 1 times 500. That's definitely not it. 50 times 10 multiplies to give me 500. And those are too far apart because those don't have a difference of 5. So I need numbers closer together. So then I would maybe consider 40 or 30. But it's looking like if I use the number 25, that might be a good number. 25 times 20 also gives me 500. And sure enough, those two have a difference of 5. So I'm going to put in plus 25W minus 20W. And if I look at these two terms, they are, in fact, they have a sum of positive 5. Okay, so I think I'm in pretty good shape. Now, remember, I still have this equation set equal to 0 because I'm still working with an equation. But what I'm trying to do now is I'm trying to factor it. Okay, so in order to factor this, I'm going to say 2W squared plus 25W plus a negative 20W, because I need to have a plus sign between my two groups that I'm about to form, minus 250. And then I'm going to group the first two terms here. I'm going to group these two terms. And then I'm going to pull out the common factor. I can pull out a W from my first two terms and get 2W plus 25. And I can pull out a negative 10 from my second two terms and get 2W plus 25. Oh, this is working out great. So it looks like this will factor to 2W plus 25 times W minus 10. Oh, 10. Okay, we're in great shape now. Okay, let me create a little bit of room right here on the side, and I'm going to go ahead and erase what I have here. Give me a little bit more room to work the problem out. Okay, so do you see my two factors? My two factors are 2W plus 25, 2W plus 25 times W minus 10 is equal to 0. I'll kind of fit that in. Okay, now we're going to split the two factors and set both of them equal to 0. And we'll solve both of these equations. So to solve the first equation, I subtract 25 from both sides and divide by 2. 25 divided by 2 is 12.5. Okay, and that should be a negative because the 25 should have been negative, so that's a negative. Make sure you can see that negative because you can't hardly see it. Then for my other one, W is going to equal 10. Now, if I use negative 12.5 over here for my rectangle, that means that the width would be a negative 12.5. Well, I can't have a negative width, so this guy is ruled out. But what about the 10? If I use the 10, that means that the width over here would be 10, and the length would be 2 times 10 plus 5. Well, 2 times 10 is 20, 20 plus 5 is 25. And both of those numbers are 5, 10 by 25. So that means that the dimensions of my deck would be 10 by 25. Our dimensions are in feet, so let's write this out. The dimensions of the deck would be 10 by 25. And we've solved the problem.